Welcome to Key Skill 4. We've just had a little smoothie break and I'm sure by now you guys need a break too. So click pause, go have a tea, go have a coffee, go have a smoothie and come back when you're feeling refreshed or like me on a sugar high. Now we're going to be looking at quite complicated simultaneous equations because we've been given U1 and U3 and we've been asked to find A and R. So let's get started. It's useful to remember that U1 would mean that it's the first term in the series. So A is always the first term. So if you have U1, you know what A is. Now we've been told U3 is 16. So we're going to start by writing out the formula. Well, we'll start with M for UN. And we know that A is 4. Now, we've been told that U3, or the third term in the sequence, is 16. So I can put this here. This must be U3, and this must be 3 as well. So all of the n's should get changed to 3, because it's the third term, U3. So U3, we've been told, is 16, which is 4 times r to the 3 minus 1 is r squared. Now we're going to make r squared the subject by dividing by 4. So moving the times by 4 here to the left, so that's r squared. 16 divided by 4 is 4, so 4 is r squared. I'm going to take the square root of both sides. Now when I take the square root of r squared, the squared and the square root will cancel down. And when I take the square root of r, I will get plus and minus 2. Don't forget both of them. In this question, I've been told if r is bigger than 0. So my final answer here will be A is equal to 4 and r is equal to 2. The next one is a tiny bit harder because we haven't been told A. We've got U2 and U4. So let's start with our formula. UN is equal to A times R to the n minus 1. Now we can say that U2 therefore would be equal to A times R to the 2 minus 1. So U2 is equal to AR. Now we've also been told U2 is 2.5. So I'm going to put that in here, 2.5. Similarly, we're going to do exactly the same process for the second piece of information. Second one was U4. So U4 is equal to A times R to the 4 minus 1. Tidying that up will give us AR cubed. We can say U4 is 0.625. Now the trick in this question is always to divide the higher power on the R by the lower one. So what does that mean? AR cubed divided by AR must be 0.625 divided by 2.5. So I take the term with the higher power of R and divide it by the term the smaller power of R. The reason why this works nicely is you can cancel off the A's and you can say R cubed divided by R, or R power 1, is R squared. And you can eliminate, you've got a simultaneous equation and you can eliminate one of the variables. So here we go. R squared is a quarter and we're going to take the square root of a quarter, which will be a half. You don't need to do that on a calculator because you can know that the square root of 1 is 1 and the square root of 4 is 2. You would have plus minus, but you've been told r is bigger than 0. So I would eliminate the negative value for r. Now, you're not finished because we're asked to find both a and r. So what you're going to do is you're going to take your r and go right the way back to the start. One of your two, you could pick either one. Substitute in one of your two equations. your value that you've just calculated for r. We now know that r is a half. So we move this times by a half to the other side by changing it into there's two ways to do this. You can change it into a divide by a half, which is a, or you can know that a divide by the half is the same as a times by 2. That fraction gets flipped upside down from 1 over 2 to 2 over 1 and change to divide. 2.5 times 2 is 5. So I've got both my values now for a and r. Very useful always to check back your answers. So for example, if I've done this correctly, which I hope I have, a is 5 and r is a half. So my answer for U4 would be 5 times by 1 over 2 to the power of 3. And that would give me 0.625. So that's correct. So after you've completed a question, you take your a and your r and you substitute it into the second equation. So I used this equation once I had r to calculate a, and then you use the other one when you finish the question to double check your answers. In a simultaneous equation, you should always use one question to substitute in and the second one to check. Now, this is a frequent exam question. It's an Edexcel favorite, shall we say. The terms p, p plus 12, and 75 form a geometric sequence. Hence, find r if p is bigger than 0. So what you need to do now is remember our trick from a couple of key skills ago, that the term in front divided by the term behind will always give us r. So we're going to do that twice. We're going to say the term in front here is p plus 12, and the term behind it is p. So that should be equal to r. But also we can say the term in front being 75 divided by the term behind being p plus 12 should also be equal to r. Therefore, these two things should be equal to each other. What this leaves me with now is an algebraic equation, and I'm going to solve it by cross multiplying. So I'm going to multiply p plus 12 by p plus 12. And here I'm going to multiply p by 75. Multiply out this bracket. So I'm going to have p squared plus 12p plus 12p plus 144 is equal to 75p. Collect together these two like terms. Now you can see that you've got a quadratic equation forming. So whenever you can see that your highest term is p squared, you want to bring everything to one side and leave nothing on the other side. So I want to move this plus 75 back to the left-hand side, so the right-hand side is empty or with 0. I'm going to slot it in here so my like terms are together. So that would be minus 75p. And then simplify that down. Now I've been left with a rather unpleasant quadratic equation. You have three options here. You can look for two numbers that multiply together for 144 and add for minus 51. You can complete the square, or you can use the formula. I think personally I'm going to complete the square. So I'm going to say p minus 51 over 2 squared minus 51 over 2 squared plus 144 is equal to 0. 51 over 2 squared $650.25. Add these two together. And bring this to the other side. Now I'm going to take the square root of both sides. So that will eliminate my power 2 here. That will give me plus or minus 22.5. And I'm going to move the minus 51 over 2 to the other side. So let's check it out. 51 over 2, the first one's going to give me 0. Well, the first one's going to give me, 48. If I add 51 over 2, which is 25.5. And the second one's going to give me 51 over 2 minus 22.5. P is going to give me 3. So these are my two values for P. Okay, so now I'm going to go back to my sequence here and do it twice, once with each value of P. So for example here, P is 48. So P plus 12 will be 60, 48 plus 12. And this will be 75. So what is my R here? Well, you can check it out. 75 divided by 60 is 1.25. And 60 divided by 48, also 1.25. So when P is 48, that will give me a corresponding R value of 1.25. Now if P is 3, the first term is 3, then 3 plus 12 is 15, and we have the last term 75. So 3 times 5 here will give me 15, and 15 times 5 will give me 75. So if P is 3, I'm going to get a corresponding R value of 5. So you've got two different answers in this situation, one for each of the R's. Okay, you made it through key skill 4. In the next key skill, we'll be looking at a different formula. I think you're probably all sick of the nth term formula by now. We're going to be looking at the sum formula. How can we add these sequences up really, really quickly? Hang on, and I will see you guys in key skill 5. Bye for now.